Yeah, sorry about that brief interruption. My postman just happened to come by. I actually live over here in the UK, even though I'm American. Uh, had ordered some Ethernet cable and then 4-core power cable for a little project I'm working on. Me and some guys at work are working on, in addition to our typical workload, something we're doing independently. Uh, what you just saw me doing is I've got lead tin solder. Uh, I like cleaning off with a little bit of IPA first. As I'm using my soldering iron, it's not good to leave the tip, to leave it on unless you have something on the tip, such as solder. You can burn up your tips easily. So I'm putting a little bit of solder on it while it's in this holder, so that tip doesn't go bad. Alright, let's see. I can't guarantee that this will work unless of that coil. And actually, this isn't really in the traditional sense a coil. What it is copper sleeve that's been glued to the diaphragm. So that way, as it is attracted to or repelled by the magnet as that AC voltage goes through, it compresses and decompresses. This is actually solid copper. Now I want to say it's going to have to fit inside of here. Hopefully that is lined up. It feels like it's going in nicely. When I compress it from the other side, I'll try not to damage the diaphragm. It feels like it's going in and out rather nice. So I got a little bit of Gorilla Super Glue as a gel. I'm going to use it to glue that magnet in place. Hopefully it won't fall out again. Just going to use a little bit. Let it cure. Or dry, or whatever you want to call it. Next thing I'm going to do, it's kind of funny. I find it rather interesting that the positive terminal of the speaker is wired through hole over to this side, but the negative terminal is not. What you have is a negative terminal going through the switch. So the switch actually doesn't turn on and off the device, although it does. It's disconnecting the flow of electrons through the speaker. The negative terminal of the speaker is actually going to here on the motor. So even though it's killing power, it's not really. I would think that, or I would want to believe that the batteries would still have some type of drain on them because of how this is wired up. So we're killing power here, or interrupting the flow of electrons from the batteries here going to the speaker versus power going to the motor. It's pretty interesting. That's not how I would have wired this up. The speaker would have been independent to the board if I was manufacturing this, because I don't presume that speaker is going to eat up the battery unless you're as much as this motor would be. But what do I know? Like I said, I'm more of a hobbyist. Just find it interesting. I might try to come in and at least, even though they're super dirty, I might try to repair this motor while I'm at it. So I don't think there's any issue with the DC motor. It is very dirty. I'm not going to get it 100% clean. It would have to be lubricated, these gears in here. But maybe I can get this axle Maybe it was stripped out from the gear associated with it. Maybe if I super glue that gear, it was probably compressed around this axle or onto this axle. Maybe it'll spin again. Again, the car's not going to go anywhere. There's no more rubber tires on it. Those have long since disappeared since I first bought this toy for my kids 2 years ago for them to play with. This is just something to, to be honest, it's going to drive my wife crazy. It being another noisemaker in the house, but any of y'all with kids would know what I'm talking about. Know what I'm referencing. When I say noise-making devices in the household, put a little bit of vinegar down in here just to clean up some of that corrosion I was seeing on this switch. Let it sit for a minute and clean it off with some IPA. Doesn't look like any of the wires are not attached. None of the wires are broken. It's kind of remarkable. Typically, with toys like this, over time, especially under the abuse of play, these wires will break down, and especially where they have been tinned at, because those are the parts that don't move. It's the copper afterwards that would move. They would wear down and no longer be attached to the board. What's nice though is, even though this is a kid's toy, everything on these printed circuit boards is well labeled. Everything corresponds to something on another board. So even these wires here, you'll see P00, P01, P02, and ground. They correspond where they're attached to on this board over here where the buttons are at. You've got your ground, P02, P01, P00. So if they detach at some point, you can very easily identify where they're going to. And maybe, just maybe, because the buttons are over here feeding into this board, maybe that's the reason why the speaker is wired up the way it is. So maybe by cutting out, creating the interrupt from the speaker before it gets to the motor, maybe that's what it is. Maybe that's interrupting the speaker and the motor at the same time. But again, I don't know without a diagram, without sitting here and trying to reverse engineer this board and where everything's attached, going to the other boards and such. But get a little bit more IPA. I'll clean off that switch. And I don't know, as this is my first video, fairly positive, actually recording anything that I do around the home. I've made other videos on other channels which are not available for the public, but mostly training videos for stuff that my team and I at work on. But where was I going? I don't know. Either way, I'm going to make a YouTube channel specifically geared towards repairing, kids' toys and stuff around the home, because there's always things that break, to be honest. And I'll leave it to y'all. There's better experts out there than me. I don't claim to be one. And if you got stuff you want to put in the doobly-doo, the comments in below, tell me how I'm doing things wrong, explain things better than I can explain them, then by all means do so. Just be polite, As Bill and Ted said, and I wholeheartedly believe, be excellent to each other. And this is just a learning process for me too. All right. So let's try to solder back in that one leg off of this capacitor. I'm not going to replace it. I've got replacement capacitors. Again, this is a kid's toy. I mean, the likelihood of another 2 years of use before it's thrown away, and you know, kids, their favorite toys change just as quickly as the days roll over. This thing will probably get thrown away at some point. I might actually keep the boards and stuff though, just for the surface mounted devices in case if I ever need spare resistors or transistors or comparators or anything of that nature, because they are nice to have around. You typically have to buy them in bulk, and even though it's not super expensive, depending on how much your bulk buy is, I mean, I still see a savings here, saving some of these things for use in other repairs. So when this does get thrown away, I'll probably keep the diodes. I'll probably keep these boards for spare. I'll probably even keep this DC motor. The switches and the plastics and all that stuff will go bye-bye. And I could see like gears like this and this DC motor and other applications, maybe like a DVD drive or a Blu-ray drive or something like that. There's got to be comparable gears, and I would presume that there's a wide range of applications just for the gears, even if it is just in another DC motor, to be honest. How do I want to repair the one lead on this capacitor? That's the question. Because it is a very small lead. There's not enough left on it to go through hole again. You don't want to make your new leads relatively super long. Spinning that out a little bit. Maybe I can just solder a bit of wire from here. Maybe I pull out this here, feed the wire through, and resolder back down on the other side. Got a solder sucker somewhere. Where is it? Alright. There. Let's see if I can get this lead on this side melted a little bit. See if I can suck it out of there. If not, I'll have to use some desoldering wick. Maybe apply a little bit of paste flux to this. So that will lower the melting point of this solder in here, which I presume to be not lead based, probably silver based solder, some type of silver alloy. That was hot. So most consumer electronics went away from lead based solders to silver alloy solders because of the fear of lead poisoning, etc. I can tell you that silver solder does not have a great eutectic state, which means over time, like you have in modern consumer electronics like your PlayStations and other game consoles and whatever it may be, over time, through repeated heat and cooling down cycles, silver solder starts to form cracks in it, which is why you run into issues like the red ring of death and the yellow light of death. Even though the solder looked like it was physically connected, or from the balls, the solder balls on the bottom of the GPUs and CPUs, etc., because they were cracked quite substantially, they were losing their conductivity between solder points on the ICs in the main board, which is why most people reflowed, and reflow can give you a little bit of help, but not a huge amount of help long term, to be honest. You actually need to form a reball of those devices. Okay, let me see if I can find some wire that I can fit through there and attach to the lead on the other side. My phone was about to die recording these videos. So what I did, or what I've done so far, recording this video, videos. It's one video, it's just multiple segments. What it is, I add an Ethernet cable that I've been using the wire in it to do some repairs around the house, and I cut myself off a little section of that wire, of one of the wires that comprises that Ethernet cable. I don't recommend doing this because it will probably ruin your tip, but soldering tip. I am going to melt away the protective layer on the outside of this wire to expose the center conductor a little bit. And this is what I will use to try and repair my kid's toy. And again, you know, I mentioned, this kind of saves me the hassle of buying a new toy, even though this toy isn't going to operate as it should. Mostly what this does for me is my kids get a great bit of joy when something's fixed again, if I fix something of theirs. And that's really what it's all about for me, is just doing something nice for my family. Make something that they cherish work again. Regardless of how inexpensive or expensive that device is. Now, the more expensive stuff we may have in our household, like our TV or something like that, those I would definitely fix, because I do not want to buy another TV, if I'm being quite honest. Alright, so do I need to trim that back a little bit more? Yeah, quite possibly. I don't have any actual trimmers, whatever the right term is for it, to pull back on this, but make do with what I have around my home. Typically, this is braided wire. It's not a solid single core copper, which I think these were all small braided wire as well. So you see me, what I'm doing is I'm twisting them together. Typically they're already twisted in here, but as I've been pulling on it, it's become a little bit unbraided. I'm going to feed that through on that side. See if I can get it to stay a bit. And then throw some solder down on there. What I'll do is I'll pull that back out for a second. Ignore the wrong way I do things, but it's a little bit of paste flux. It'll help with the solder flowing onto this wire. Solder it into this PCB. something you should also know about flux. And they do make the type of flux that is no clean. This is not a no clean flux. This is rosin solder flux. Flux itself is good for cleaning soldering joints and allowing for your solder to flow, but if this type of solder is left behind long term, it can create corrosion as well, start eating away at components. So it's not really the right type of solder to use in the application, or flux to use in this application, but I'm also just using minimal amounts. Alright, so what I did is I put a little bit of solder on my lead, then I'm allowing that solder touching it to that specific wire here and allowing it to heat up the wire to attach it to make that hard mechanical connection. Put it in those terms. Now how am I going to attach it to this other side? I should have thought through this a little bit better. Let me see if I can bend this other capacitor out the way a little bit. Then bend this one down this way. Hopefully not tearing up the leads. And maybe, just maybe, I can get it to get positioned in a way that's going to attach better. I'll apply some solder to it. Okay, that's resting on there a little bit. I know it's a little bit hard for you to see based off of how I have this position. I'm not sure if I can zoom in anymore. But essentially, I've got the wire resting on the broken lead going to this capacitor. And I'm going to use my soldering iron and a little bit of solder applied to the tip. See if I can get those 2 points soldered together to reestablish that electrical connection. I probably should have applied some flux to that to help ease this up, ease this process a little bit. Use these nice set of tweezers here to facilitate that. And of course I want to clean these off really good later, but okie dokie. See if I can get these to make a connection. And of course, because I don't think through things, I have my paste flux resting where it's going to fall. Okay, so that is attached. That's attached. I'll lay this capacitor over, and I think that's going to work. It's going to be a permanent fix. Who knows? Kid's toy will probably break again. But at least for now, that is making a physical connection. Alright. I am seeing a broken wire here too. Might be due to me moving things around. That's going to have to get repaired too. I wasn't really wanting to do anything like that. That came off of here. So it looks like we've got a little bit more to do on this board before we can button it back up.